This quiz review will discuss graphing polynomials. The function that's shown is what the graph looks like if you were to actually graph it. So looking at either the function or the graph, I can determine my degree, which is going to be the 5th degree. And I also want to know whether or not the graph is an odd graph or an even graph. If the arrows are pointing in opposite directions, then it is going to be an odd graph. Your leading coefficient, the sign, is actually telling me that the end behavior of my graph is pointing downward. So therefore, my leading coefficient should be -1. In this case, it is -1. My zeros can be identified by looking at my x-axis. Where does the graph actually touch my x-axis? So I see 3 points, but I said my degree was 5, and we've learned in class that whatever your highest degree is, that's how many zeros that you will have. Some will be real and some will be imaginary. So in this case, we have 3 real because they appear on your x-axis, and the other 2 will be imaginary. If we went to, let's say, Desmos, and we entered in the function as shown here, if I look at my graph, all I would have to do is to just click on it, and Desmos will actually give me what my zeros are. And I know that my zeros are also known as x-intercepts, roots, and solutions. On my graph, more times than not, it's known as x-intercepts, but I use the terms interchangeably. What I'm looking for is where y is 0. So as I stated before, I see that I have 3. So they're at -2, 1, and 1.839. So that's what I'm going to write over here. And I like to write mine in a set format, but you don't have to. -2, 1, and 1.839. My y-intercept is where my graph crosses my y-axis. In this case, x has to be 0. So -2. If I went back to my Desmos, again, if I just clicked on it, it will tell me it's 0, -2. And let's see, if I'm looking at my local max and my min or minimum, what that means is for the max, where is your, it looks like a mountain or a hill, where's the highest point? And then for your minimum, it looks like a valley or a U. So if I'm looking at it, I'll show you here, and then I'll go back over to Desmos so you can see how you can quickly grasp it or get the information. I can't have more than one. Max and minimum means my y value. So that's how I write it out. And let's just go over there actually. So for the ones that, let me get rid of this because that can be confusing here. So that's a maximum. Can you see that? And then here's another maximum. So I have 2 maximums, and I'm looking at the y values only. Let me get rid of everything else so I don't confuse. So I'm only looking at the y values. When I go back here for maximum, I'm going to write y is equal to -1.805, and y is also equal to 2.414. So that's this point and this point that you can't really see it on this one because the numbers aren't there. So if I went back and I went to my minimums this time, I'm going to deselect that. The lowest point, I'm looking at the y value, and the same here. So I have 2. And I'm going to do the same thing and write it as y equals. So for one of them, y is equal to -6.414. And for the other one, y is equal to -2.195. So in my graph over here, that's a minimum, and there's a minimum. Yes, just wanted to make sure I wrote the numbers down correctly. So my max turn is 1 less than whatever my degree is. So if my degree was 5, then I have 4 turns. If you just wanted to follow it, what you're doing is you're going down, you turn once, you turn twice, 3 times, 4 times. Now I can add 1 to that, or again, like I said, it is going to be, so my max term is going to be 1 less than my degree, or my degree is going to be 1 more than my max terms. All right, for my intervals of increase and decrease. So what I'm going to do here is probably, I'm going to try to color code it for you so maybe you can follow better what's going on. If I am using my finger or a pen and I'm just tracing the graph from left to right, the first thing I'm doing, even though the arrow is pointing up, is I am going down. You take your finger and you actually trace. What am I doing? I'm going down. And then I'm going to go up. So I'm going to change the color so you can, oops, see that. And then I'm going back down again, taking my finger or my pen. Then I'm going up. And one more time, I'm going down. I can take that information that I just color coded and I can put it in the form of my intervals increasing and decreasing. So the blues were going down, they're decreasing. My intervals, anytime I see the word interval, then I'm going to use my X values. If you don't know that, write that down somewhere. So X values. What that means is I'm actually taking this arrow and I'm stretching it out to the left, which means it's coming from my negative infinity side. On this side, this confuses students sometimes because it's going down. Well, it looks like it's going down, but we don't want the Y value, we want the X value. So if we stretch that out to the right, guess what? That's actually positive infinity. So that is a common error. Looking at the blues, we started from negative infinity, and just because it's negative infinity does not mean that it's going to automatically be with the decrease. You just have to follow your finger. So negative infinity, and then we stopped at the first X, which was negative 1.521. Well, from that negative 1.521, we had to pick up and go up. So we increased. So I'm going to use that same number, negative 1.521. And I kept going until I got to negative 0.294. So right here. And now I have to pick up from there and I'm going down. When I have multiple intervals, I'm going to use a union sign. And that's kind of there. All right, so now I go from that same number, negative 0.294, and I go to positive 0.294. So from here to here, I went down. And I have to go from negative 2.294 up to 1.521. So this time I'm going up, I'm going to use a union, 0.294 to 1.521. And then finally, I'm going to go down from there, but I'm going down, but again, remember, this is actually my X value. So if I straighten this out, I'm actually going to positive infinity. So the last interval is 1.521 under my decreasing, and it goes to positive infinity. I know that I'm on the right track if I have accounted for 1 negative infinity, 1 positive. I should not have 2 of the same. And then my numbers are overlapping. Let's see, this one, and finally this one. So those are my intervals of increase and decrease. If I am referring to my positive and negative intervals, what I tell my students in class is visualize yourself on a train, I don't know, and ignore how my train looks. This is just to kind of help you see what's going on. There's my train, and all of my X axis has to be my train track. I'm always going to start from negative infinity. That's the first place that's on my X axis. And I can keep going until I can get to positive infinity. So again, my train has to account for all the X's that are between negative infinity and positive infinity. So I'm going to stop at every x-intercept. And what I'm looking for is, am I stopping in a positive area where my graph is above my x-axis, or am I actually stopping in the negative area where my graph is below the x-axis? So starting from negative infinity does not necessarily, it does not mean that I automatically go to negative. That's a common error. I have to look at my graph. My graph is it's above x-axis. Again, I'm looking at the x values if I see the word intervals. And if that arrow was actually stretched out to the left, well, x is negative infinity, but it's above the x-axis. So I am going to start with my positive value intervals. So negative infinity, my train goes choo, 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 and it stops at my first x-intercept, or zero, or solution, however you want to say it, which is going to be -2. All right. So from -2, I am going to leave that and I'm going to go into the negative section. So all of this from -2 to my next x-intercept, which is +1, my graph falls in the negative portion, which is underneath the x-axis. So from 1, I go back up to the positive section. So I'm always overlapping the numbers and I'm just determining where is my graph going. Is it going from the negative, or is it going to positive? So I went back up to the positive land, 1 to, this time I went to the other x-intercept, 1.839. And then my train made its final stop from, well, it went from 1.839 all the way to positive infinity. Again, this is really my x values and it's stretching towards the right. So if it's going to the right, that means it is always going to be positive infinity. However, I'm in the negative section of town. So I want to change this to 1.839 going to positive infinity, even though it's in the negative interval. I hope that made sense. So that's the difference between the intervals of increase and decrease and positive and negative intervals. They're both using the x values, but just make sure you understand one of them means I'm going from the highest point to the lowest point, or vice versa. The other one is asking what is above the x-axis versus what is below the x-axis. Okay, I can't get my, all right, so now what I want to do is, don't know why that won't disappear for me. Come on. Domain. If it is an odd graph, your domain will always be all real numbers. So that's always going to start with negative infinity to positive infinity. You never have a positive infinity first. You never have a negative infinity second. Always start from negative infinity to positive. Got it? Okay, for my range, again, if my arrows are pointing in opposite directions, so one could be up and the other could be down, or it could start off with the down and up, then your domain and range will both always be negative infinity to positive infinity. Why? Because if I were to stretch this up and stretch this down for my range, it's going to go on forever. If I stretch the arrows left and right, it's going to go on forever. Not sure why my undo is not working all of a sudden, but it's okay. All right, my end behavior is asking what is happening with those arrows. So as I am going towards negative infinity, what is happening with my arrow, my first arrow that's closest to it? Is it going to positive infinity on y? Because f of x means y. Or is it going towards negative infinity on y? Well, I can look at that and see that it's going towards positive infinity. And then if I am going towards x is positive infinity, what's going on with the arrow on the graph that's nearest to me? Well, this time the y is going towards negative infinity. And that is the characteristics. That's how you identify the characteristics on the graph. Now, there's one more example I wanted to show you, which is how you look at a graph and determine your zeros and put it in factor form. So this is a different graph. On this one, I've already highlighted my zeros. And just so you know, this is actually a 7th degree polynomial graph. Yes, I only see 4 zeros, but if I understand multiplicity, I actually see more. So for my zeros, I have x is equal to -1, and that is known as a snake when it slithers like that or lingers around that point. So that means it's going to be a multiplicity of 3. And then I also have a point or 0 at 0, the origin itself. And that is just a multiplicity of 1 because it's just going through that point one time. I mean, straight through. At 1, I also have another 0, and the multiplicity is simply 1. It's a straight through type deal. And then lastly, for 2, I have a multiplicity of 2. And that's known as the bounce that I talked about in another video. So if I can get my zeros from my graph, then it's easy for me to put it in factor form. All I need to do is either put f of x is equal to or y is equal to, it doesn't matter. So y is equal to, if you have a 0, go ahead and list that first, because technically what this is, if I rewrote it as x separated for all of them, is x is equal to -1 3 times, x is equal to 0 1 time, x is equal to 1 1 time, and x is equal to 2 2 times. So that's what the multiplicity means. So when I am trying to put it in factor form, I always want to start with my 0. I want to put, for me, that's what I want to do. So I'm going to put x by itself, because again, if I move this over, I told you this in class, all I'm doing is working backwards. I'm going to move the number over to the other side with the x and just change the sign. If I move a 0 over to the other side with x, nothing happens. It's just simply x. So x is its factor. So I'm done with that one. The next ones, it really doesn't matter which order. I'm just going to go from left to right, starting with the x equals -1. So that now becomes x plus 1. I have to remember the multiplicity of 3, which is going to represent my degree. So this is going to be raised to the 3rd power. And now I have to go to the next one and move the 1 over, change the sign. So it's going to be x minus 1, but it only counted as 1. There wasn't a multiplicity. So the degree is just 1. I don't have to write it there, but if I did, that's what it would look like. It's just understood a 1 is there. And then finally, if I move the 2 over, I have x minus 2. And since there's a multiplicity of 2, that means it's raised to the 2nd power. So this is what my actual factored form of this graph